Hello everyone. Today, I'd like to explain how transparent data encryption works in GaussDB. This walkthrough has three parts. First, let's dive into why GaussDB offers transparent data encryption. To defend against attacks and ensure data security, conventional databases rely on a multi-layered protection system. To illustrate this, there are several key security measures commonly used. The first is secure transmission. Security protocols such as TLS ensure the confidentiality and integrity of data exchanged between applications and databases. This prevents attackers from eavesdropping, forging, or tampering with data during transit. Next is identity authentication. This occurs at the database layer. It verifies user identities using IP addresses, passwords, and certificates to prevent unauthorized access to the database. Following authentication is access control. The database employs multiple access control mechanisms to limit the scope of attacker access to database objects. Then, security audit. All actions performed within the database are logged to track changes and identify any suspicious activity. Finally, data masking. Sensitive data within databases is masked to block unauthorized access and protect against potential breaches. However, attackers can sometimes bypass these layers and steal data directly from storage. This is where transparent data encryption comes in. GaussDB provides transparent data encryption to address such problems. All data is written to disk in ciphertext. Even if an attacker gains OS-level access to the files, the content remains unreadable, blocking any attempt to sidestep database privileges or steal data directly from disks. Transparent data encryption delivers secure storage protection while maintaining database performance. Here's how it works. The encryption-decryption process happens seamlessly in the storage layer, while the execution module processes data normally. This ensures there is no impact on computational performance. For authorized users, everything works exactly as before. They access data normally with zero awareness of the encryption and decryption. But for attackers who steal database files, they only get encrypted gibberish, which is completely useless without the proper decryption keys. Transparent data encryption provides three core capabilities: automatic encryption of all files within the databases, seamless encryption and decryption with no noticeable impact on user experience, robust protection against OS-level privilege escalation and physical theft. The primary use cases of transparent data encryption include securing stored data and replacing the transparent data encryption solutions of other database providers. Transparent data encryption delivers key benefits across three critical dimensions. First, security. Transparent data encryption safeguards against static data leakage by preventing unauthorized access to database files, even if attackers bypass the database authentication mechanisms. Second, ease of use. Tables and indexes can be explicitly encrypted at creation using simple SQL syntax. The encryption process is completely transparent to users. Third, performance. Data is encrypted only when written to disk, and encryption occurs at the table level. This minimizes impact on database performance. You can enable transparent data encryption in GaussDB either during initial instance creation or for an existing instance. For a new instance, during creation, you can set the transparent data encryption option to enable and select a prepared key to enable this feature. It will be immediately available after the instance is created. For an existing instance, you can navigate to its basic information page, click Enable in the transparent data encryption field, and then select the created key to enable this feature. Then, reboot the instance to apply the configuration. Note that the encryption key cannot be changed once transparent data encryption is enabled in either scenario. Now let's explore how to implement and verify transparent data encryption in practice. When creating a table or index, simply include the with clause in your SQL statement to specify encryption. Let me walk you through an example with table T1. As shown in the example, when creating a table, use the with clause to set the enable TD parameter to designate T1 as a TD encrypted table. Then, insert and query table data normally. the specific data information can still be retrieved for the query. Encryption is completely transparent to users. If we inspect the physical storage, we can see that encrypted tables show only ciphertext, which is completely unreadable. In contrast, unencrypted tables reveal plain text data. Transparent data encryption guarantees that even with direct disk access, attackers get no usable information. After the verification is complete, remember to drop the test table like T1 in this example. That's all about GaussDB's transparent data encryption feature. We hope you find this video helpful. You can visit our help center to learn more.